Welcome to the lecture on compounding frequency of interest. So, this is a very important aspect to be known to us, that when we are dealing with these financial mathematics and financial transactions and we are involved, we have to involve these financial institutions who charge interest, then we must know that how this interest is being charged. So, when we study about the interest in normal cases, what we talk is maybe 10% interest or 7% interest, and normally that is assumed that it is annually. So, in a standard manner, it is assumed that the interest will be always compounded once the year completes. So, after the year, again the interest accumulated will be again a part of the principal amount for the interest calculation in the next year. So, that is a normal notation or normal practice when we are dealing with the compound interest. But then in many cases the interest is basically applied many times. It is not that we are only doing in a year. So that is how the interest is applied many times, and many a times that is why the interest is to be paid more frequently, not necessarily after 1 year only. Means that after suppose 6 months the interest will be charged. So, suppose there is amount of 100 and there is 8% of interest per annum compounded annually. So, that is in a standard manner. If you have rupees 100 and if the interest is to be calculated. So, suppose 8% interest is there. So, in a normal circumstance, that means that after 1 year first year the amount becomes 108. Now, so this is 8% interest per annum. So, this is compounded annually. In the second year again there will be 8% of 808, that will be the interest. So, it will be 108 into 0.08. So, it will be 8.64. So, ultimately it will be 116.64, like that. However, if you just take the example that you are dividing this interest in 2 installments, you are taking 8% in a year, but then 4% in the first half and 4% in the second half. So, that is basically we are increasing the frequency of the compounding of interest. That is what we mean in this case. So, we are talking about the compounding frequency of interest. So, in that case, if you are using 4% interest every 6 months, so what will happen that after after 6 months the 100 rupees will become 104, and after another 6 months, so it will be again so it will be 1.04 into 104. So, basically it becomes 108.16. So, that is basically this is 4% interest every 6 months, and the terminology, standard terminology what is used is that 8% interest compounded semi-annually, that is what we call it. So, because we are basically compounding the interest in 6 months, so that is why we call it as compounding semi-annually, and then you see that this becomes 108.16 instead of 108. So, the interest amount which was earlier rupees 8 on rupees 100, that is the principal amount. So, that became 108.16 when the interest was compounded semi-annually, or the frequency was 2 times in a year. So, that is the basically difference between compounding frequency of compounding of the frequency of interest which is charged. So, if you go to further, it will be further changed. So what happens that the future amount will be changing, and many a times so when this is done for suppose so 2 times, we can do it for 4 times, 8 times or 16 times or 52 times, I mean every week, or we can do every day or even continuously, that also we will discuss. Now, what is the effect of such changes of the interest which is done in the case of the compounding frequency of interest? That is what we need to study in this chapter. Now, the thing is that so as we discussed that it will be varying from half of the year. So, that is known as compounding of interest twice in the year. Then 1 quarter of year you may have the compounding. So, that becomes 4 times in a year. Then you may be doing the daily. So, you may have 365 times in the year. So that way you have the different notation of mentioning the names, how the compounding is carried out. So, compounded semi-annually or compounded quarterly, compounded weekly, compounded daily, like that you have different way of expressing these compounding frequency of interest. Now, the actual or effective interest rate of 8% compounded each 6-month period is also expressed as annual or nominal interest rate of 16% compounded semi-annually. So, what we see that there are 2 terms, one is the nominal interest and another is the effective interest. Now, when we talk about this term, like you have 16% compounded semi-annually, so that is what the nominal interest nominal term is, and that is what we call it as the nominal interest rate. So, in a year it will be 16%, but then compounded semi-annually. Now, if you look at the effective interest for the whole year, if you look at, in that case it will be different, it will be 16.64%, 8% every 6 month. So, in the 6 month 100 rupees will become 108, and then another 6 month it will become 116.64. So, basically when you call it as nominal interest rate of 16% compounded semi-annually, then the effective interest rate for the year becomes different, and that becomes basically 16.64%. So, basically you have 2 terminologies, 2 terms of interest. One is effective interest or actual interest rate, and then you have the nominal interest rate, what we denote it as. Now, nominal interest rate is expressed on annual basis and is obtained by multiplying the effective interest rate compounding by compounding frequency per year. So that is how we basically express it on the annual basis. So, that is your nominal rate of interest. So, basically compounded semi-annually or whatever. So, suppose the effective interest rate for 3 months is 3%, it means nominal interest rate will be, so it will be done 4 times. So, that is what we are multiplying that. So, it will be 3 into 4, so 12%, and then compounded quarterly, that will be your nominal interest rate. That is how we express the nominal interest rate. Now, how we are basically defining this nominal and effective interest rate. So, the effective interest rate I, it will be equal to 1 plus r by m, and then raised to the power, whole raised to the power L into m minus 1. So, that is what this is the formula for the effective interest rate. Now, what are the terms here? This r is basically the nominal interest rate per year. So, that is what we discussed, that if it is 16% compounded semi-annually. So, in the whole year whatever effective interest you have to find and you have to multiply with the number of times, that becomes your nominal interest rate value, and compounding that many times, that is how you use that term. So, that will be your nominal interest rate per year. Then your L is the length of time interval. So, in how much time you have to have this, and then M will be the reciprocal of the length of compounding period in years, and when interest is compounded only once in the interval, then L into M has to be equal to 1. So, that is how you define this nominal and effective interest rate as. So, what we do is that we can see that how how we try to see that how they are changing. So, for example, you can say that if suppose you have 12% of nominal rate and compounded monthly with time interval of 1 year. Now, suppose you have to find basically the effective interest rate in a year, and the nominal interest rate is 12% compounded monthly. Now, in this case, if you look at this formula, so what we see is that your length is, so if you see now in this case, your L is your length of the time interval in years. So, from here you can directly write L will be 1 year, because you have to find the effective interest rate in the year. Now, M is reciprocal of the so that is shown that M is basically the reciprocal of the length of compounding period. Now, compounding period is basically here, compounding period is 1 month. Now, M is reciprocal of compounding period in years. So, here in this case it is 1 month. So, 1 month is nothing but 1 by 12 years. So, it will be reciprocal of it. So, it will be 1 by 1 month, basically 1 by 12 years. So, it will be 12. So, your L becomes 1 and M becomes 12. Now, you have to fit in to the equation which is basically derived or which is given to you, that the effective interest will be 1 plus R by M raised to the power Lm and then minus 1. So, if you take the effective interest for this 12% interest compounded monthly, and for the interval of 1 year, it will be 1 plus your interest rate is nominal interest rate is 12%. So, it will be 0.12, and M, that is your reciprocal of the compounding period in years, that becomes 12, and then it raised to the power L into M. So, we know that L is 1 and M is 12. So, it will be 1 into 12 and then minus 1. So, it will be basically 1 plus 0.01 raised to the power 12 minus 1, and if you do that, you will be getting 0.1268, that is 12.68%. So, that is how you should not get confused with this way of presenting this interest, that in this case if you see now this is your interest of 12% compounded monthly, means every month end you will have the compounding. So, basically 100 rupees if you have, 1% will be compounding. So, it will be 101 rupees after first month, then again 102.01 rupees in the second month, like that it will go. And if you calculate for the 12 month, then in the end of 12 month it will be 112.68 rupees, and that is why your effective interest for the period of 1 year it becomes 12.68%. So, that is how we basically calculate the effective interest for any period when your nominal interest rate is given to be calculated. Now, we are going to have the solution, I mean examples, different examples of the different cases. So, if you go further and if you try to see then how it looks like. So, next you have nominal interest rate of 9% compounded monthly, the effective interest rate per month. Now, what will be the effective interest rate of 1 month? Now, if you try to see this question, it is very clearly seen that the nominal interest rate is 9% and you have to find the effective interest rate in a month. So, effectively you are so it is written that it will, the interest will be 9 by 12%. Every month you have to use 9 by 12%, and since you have to apply only in a month, so it is very simple that it will be 9 by 12%. So, it will be 0.75%, but how can we use the formula to get it? So, your question is that nominal rate is 9% compounded monthly, and effective interest rate. So, you have to have effective interest rate per month. So, in that case if you look at that, so effective interest rate will be 1 plus. Now, in this case your nominal interest rate is 9%, so it will be 0.09. Then you have to have per month. So, compounding period is 1 month and its reciprocal will be basically so it will be 1 by 12 years. So, it will be 12. Then L into M. So, L is your time, that is your 1 by 12, because you have to find effective interest rate per month. So, L is 1 by 12 and M is 12. So, your L into M becomes in this case 1. So, it will be 1 and minus 1. So, if you calculate the value, it will be 1 plus 0.09 by 12 minus 1. So, it will be 0.09 by 12, that is 0.75%. So, it will be 0.0075. So, it becomes 0.75%. As usual, it is very simple that when you are defining itself that 9% interest rate and then compounded monthly. So, it is basically the effective interest rate for every month, and only we are talking about every month. So, that is how we calculate it. Next we can have the question. Next is that it is nominal rate of 12% compounded monthly with time interval of 1 year. We have already done it. We have seen that 1 plus 0.12 by 12 and then raised to the power 12 minus 1. So, it becomes 12.68%. Next is that we have a nominal rate of 18% compounded weekly with a time interval of 1 year. Now, let us say in this case you have a nominal rate of 18%, then compounded weekly with a time interval of 1 year. Now, in this case, as you see that you have R is 18%, R is 0.18, then L is given as 1 year, so it will be 1. Then M, now M is basically compounding period is weekly. So, weekly means it is 1 week, so 1 by 52 year, because if you assume that there are 52 weeks, in that case you have M is 1 by 52. So, it is reciprocal of this. So, it will be 52. So, now you can see that your effective interest will be, now in this case 1 plus R is 0.18, then by M is your 52. Now, L is 1 and M is 52. So, L into M is 52 and then minus 1. So, this is how you are going to calculate the compounding compound interest for 1 year, effective interest for the whole year, and that if you calculate, it will be coming to 0.1968. So, it will be 19.68%. So, if you see that in normal case you are having 18% compounded, 18% becomes, and if you compound it weekly, then its value becomes equal to 19.68%. So, that is how we calculate these values. Next we will further see the next question. Then you have a nominal rate of 14% compounded monthly with a time interval of 6 months. So, now we have to again see this different type of problem. So, this problem is that nominal rate of 14% compounded monthly with a time interval of 6 months. Now, in this case, as we know that your R is 0.14 and time interval we have taken as 6 months. So, you have for this time interval you have to calculate. Now, what happens that this is monthly. Now, time interval is since 6 months, it is half of the year. So, your R is becoming as 0.14 as usual. Then L we have to do for how much time you have to calculate. So, that is 6 months. So, it will be 1 by 2 years. Now, M is, since it is compounding is done monthly. So, it is 1 by 12 years and it is reciprocal of 1 by 12. So, it becomes 12. Now, based on that we can find the effective interest, and it will be 1 plus 1.14 divided by M. So, it will be 12 raised to the power L into M. So, it is half into 12, that is becoming 6 and then minus 1. So, this becomes equal to 7.21%. So, otherwise it was 7% in the half year, that becomes 7.21% when we talk about the compounding, and compounding is done monthly. So, that becomes equal to 7.21%. Then next is nominal rate of 10% compounded weekly with a time interval of 6 months. So, this will have again in a different way we will solve. So, this is nominal rate of 10% and then this is compounded weekly with time interval of 6 months. Now, as you see that in this case again you have R is 0.10. Now, L is your time interval for which you have to calculate the effective interest is 6 months. So, it will be 1/2 years, 1/2. Then M is it is compounded weekly. So, reciprocal of that in years. So, weekly means 1/52 years. So, M will be 52. So, you can have the effective interest rate as 1 plus R by M, M is 52 raised to the power L into M. So, L is 1/2 and M is 52. So, 1/2 into 52 is 26 minus 1, and this becomes equal to 5.12%, and this is per 6 month. We will have to write this effective interest. So, here it is again per 6 month. So, this is the effective interest we must write down, because here also we are so this is per year. Now, similarly we are coming, this is per month. So, this will be per month, like that we are calculating every time. So, you have to basically mention what for what time you are calculating the effective interest. Now, next we may have the further there is a problem of nominal rate of 13% compounded monthly with a time interval of 2 years. Now, again we can see another type of example where it is rate is 13% compounded monthly and you have the time interval of 2 years. So, nominal rate of 13% compounded monthly with time interval of 2 years. So, in this case what we see is that your R becomes certainly 0.13 and compounding is done monthly and your time interval is 2 years. So, L becomes 2, L becomes 2 years. Then M, it is done monthly compounding. So, M will certainly be 12, because it is 1 month. So, compounding is done every 1 month. So, 1/12 of the year, and that becomes 1/12. So, it will be 12. So, if you find the effective interest, it will be becoming 1 plus 0.13 divided by R by M. M is 12 raised to the power L into M. L is 2 and M is 12. So, it will be 24 and minus 1. So, this will come out to be 29.51% per 2 year. So, basically we are interested to know the value of the this effective interest rate in the span of 2 years, and for the span of 2 years your effective interest rate becomes 29.51%. In normal case you assume that 13%, so 2 years will be 26%, but since compounding is done monthly, so it is increasing that much fold and it becomes 29.51% per 2 years. So, when your that period for which the effective interest rate is to be computed, it becomes more and more, effectively it becomes the computed value becomes more and more. So, that is how you calculate those. Then you have another example of nominal rate of 9% compounded semi-annually with a time interval of 2 years. So, you can again see that if you have a problem of nominal rate of 9% compounded semi-annually, and then you have with time interval of 2 years. So, Now, in this case again now things are, I think hopefully you have got the confidence to talk about it. So, your R becomes 0.09 and you have again L as 2, and since it is done semi-annually. So, M will be reciprocal of 1 by 2 years. So, it will be 2. So, effective interest rate will be 1 plus 0.09 divided by M. So, 2, and then L into M will be 4 and minus 1. So, it will be 19.25 percent. So, basically for the 2 years it will be 19.25 percent. That is how you are getting this. So, this is for 2 years. So, this is the different types of examples that we have seen how to compute these effective interest rate values. Then what we see that in such cases we can quite clearly visualize that how this effective interest rates are computed, and based on that. So, basically we can also do for daily basis. So, in that case you have to divide it by 365 because, and then you have to have the appropriate exponent is to be taken based on the different conditions, and then you have to compute. Now, in the next lecture also we will discuss about the case of continuous compounding, where basically when there is infinite number of times your compounding takes place, then it is a case of continuous compounding. So, that we will discuss, and how the interest rate varies. So, that we will see in that lecture. Thank you very much.